This is Small Dose Physics, Blurb 2. Measured numbers. In physics, most numbers come from measurement, and therefore have units attached. The unit attachment to its number can be considered a mathematical multiplication. Therefore, if you have, say, 12.6 centimeters, it can be considered to be 12.6 times centimeters. We understand, with the understanding, when measured numbers are mathematically manipulated, as in multiplication, division, squaring, square root, etc., the units are also manipulated in the same manner. So, suppose we have a length of 12.6 centimeter, and it is to be divided by a time interval of 2 seconds. What's the answer? Well, 12.6 centimeters divided by 2 seconds would give you, for the numeric part, which can be solved by a calculator, although this one is too simple perhaps for that, a standard calculator, a scientific one of very less than $10 could be used for most of your physics calculations, by the way. Anyway, the numeric part is 6.3, and the unit part would be simply the written centimeters over seconds, which is said to be centimeters per second. So the answer would be 6.3 centimeters per second. And I underline this. You can mark your answers any way you want, circle them, but they should be in some way marked. This is one of the principles of probably math and physics. In like manner, measured numbers can be multiplied, divided, squared, etc. So, if a time interval of 2 seconds is squared, you would get 4 seconds squared, 4.0 seconds squared in this case. And if 12.6 centimeters was multiplied by 2 seconds, you would get 25.2 centimeter seconds. Numbers in physics, therefore, fall into, let's say, 2 categories. That is, numbers with units. There are numbers that directly come from a measurement that have units, and there are numbers that are generated by the math, where you have at least one measured number in the math. From now on, unless specifically stated differently, the word numbers, given in this blurb or in future blurbs, means numbers with units. In other words, the majority of physics numbers. It is useful to know that each unit has a universally accepted abbreviation, and it will be necessary to learn these. One hint is not that you shouldn't make up your own abbreviations, but learn the accepted abbreviations. You already know some of these, of course, from chemistry and other courses. Fortunately, new units are introduced slowly, so you should have little trouble in learning the accepted abbreviations. Now here we have a model, a diagrammatic model of problem solving in physics. You start with data, and the data is manipulated in some kind of a calculation, and then you come out with the answer. Very simple model. What you should know about this is that all data in physics problems must have units, and all answers must have units. Often the data is something that you get as a given, especially in textbook, teacher tests, etc. So you don't have to worry about the units in that case. But in laboratory, where the student is measuring, you will have to remember to write down the units with the numbers. And of course, any answer to a problem will have to have the units attached. The interesting thing is that units is not required for calculations. More about that later.